we're gonna start with complex numbers.
Complex numbers.
Complex numbers. Do you still remember this topic, Musa?
Yeah. I do it every day, this one.
Okay, nice. I carry complex numbers can be expressed in several ways. We have the standard form, which is a plus bi, and then we also have the what's the other one, Konji? A polar form, right?
Colorful.
Yes, we have the polar form. We have the polar form. So the polar form is r cis theta, and then what's the other one?
R, that thing of
Yeah,
the box. Yeah, that one.
yes,
That's
this one,
it.
this one, this
And
one.
the other one of, is it the polar form of R, open brackets, sine,
It's cos,
cos
yeah,
theta,
theta
cos
plus
theta plus I sine theta.
I sine theta. Yes, this is also considered a polar form, but it's a way of changing a polar form back to a standard form as well. Yeah.
Oh, okay.
All right. All right. So, what did I say in class again about working with polar forms and standard form? So, the polar form, it's good for dividing. It's good for dividing and multiplying.
Fine.
As for a standard form, Yona, it's good for adding and subtracting, right? And subtracting.
Yes.
And subtracting. Okay. So we're gonna take a question from a question paper, né? We're gonna take a question from a question paper and discuss that. So let me just go and copy that question paper. Okay. Well, more especially for paper one, complex numbers has a lot of marks, man. A lot of marks.
Yeah.
Gary, complex numbers has a lot of marks on the question paper. On the question paper.
Yeah. And I think it's 30 something percent.
It's a lot. It's a lot. It's a lot. Okay, maybe we can start here. Ne? We can start here. So
Okay.
we want to simplify the following complex numbers and leave answer in the form of a plus b j. Calculators may be used. So there's another thing I discovered, man. Guti, you actually can use the black calculator to work with complex numbers. I don't know, you get why you check that thing now.
On a calculator.
Yeah, on that black calculator you actually can. There's polar. We are gonna
Uh,
wait. Do you have a calculator yako, the black one?
yes.
Okay, check out the plus sign and the minus sign. Do you see a pole above plus and a rec above plus?
Yeah.
Okay. You can actually work with complex numbers with those functionalities. Ne? Um,
Mm.
but right now angikhona ukukhombisa i-calculator yami so that ngi-demonstrate this thing. I'm gonna show you in class. I'm gonna share with the class as well. So 2.2, 2.2.1. You know what? Let's do this one
Mm.
together. Equal to All right, so what do we do with the first term inside the bracket?
The first term,
Yes.
the square root of 125, ne?
Oh, yeah, square root of 125. I'm getting a 5 root 5.
Uh, uh,
5 root 5.
yeah, it's 5 root 5.
Okay, what about the square root of negative 25?
You have to take a, I don't know how to explain,
Okay, okay,
but
okay.
what I know is that you need to have a negative one times 25.
All right. The reason for that is
Yeah,
because uma uthi square root of minus 25, you get an error. Angithi? You get an error.
yeah,
So
yeah,
you
yeah, yeah.
the calculators we are using, they are not smart enough to work with our complex numbers. There are calculators, uma uthi square root minus 25, ikhiphela the complex number, right? Ikhiphela the complex number.
Yes.
But for this one, we're gonna say square root 25 multiplied by the square root of minus 1. So we separate minus 1 from the negative 25. And then we're going to
Yeah, yeah.
close. We're going to close. Remember, show all steps. Show all the steps. Show all the steps when you calculate. And then we do the same with the square root minus 125. So it's going to be a square root 125 multiplied by the square root of minus 1. The square root of minus 1 minus okay, what's the square root of 25? Is just 5, right? It's just gonna be
Yes.
5. And then for this one, it's square root 5 square root 5 minus the square root of 25, it's 5. And then here we're gonna have the I square root of minus 1, it's I. Then lana, it's gonna be the square root of 5 square root 5 and the I, as well as the I. And then we continue. Let me close the bracket for now. All right, so now that we have simplified our square roots weight, we can now start removing our brackets and simplify further. Minus 5i minus 5 square root 5i plus 5. Then this one and that one are like terms, ain't it? But unfortunately, we cannot add the two. We cannot add the two. We cannot add the two. And then same goes with this one and that one. They are also like terms by the I. However, we can write it like this. Remember, batisi pale as a plus b I, right?
Mm.
So we're gonna say 5 square root 5 plus the 5. This is the a, right? It represents to a. And then here it's gonna be a minus open bracket 5 plus 5 square root 5 and the I outside the bracket.
Oh, so there's no need to write the, let me see, where is it? Like 5i plus 5 square root 5. So I have to separate the I, put everything in bracket, and I must be at the end.
At the end, at the end, at the end, at the end, at the end. Okay,
Oh,
but another thing you can do, ne? You can also write it in decimal as well. So you're just gonna add the 5 square root 5 plus 5, and then you're gonna get a 16.18 minus, and then you're gonna have a 5 plus 5 square root 5 equal to, then you're gonna, you also gonna have a 16.18
16.
I. So this is gonna be your final answer. You can also leave it like this in decimal form, right? In decimal form.
I see. I see.
All right, let's move on to the next one. Let's move to the next one. So for this one, We have to use I properties to simplify again.
Yes.
So I have the 24, I have I raised to exponent 8. I have to say I squared, outside the bracket I'm gonna have a 4. I'm gonna have a 4 minus 36, and then it's 16, it's j. I'm gonna raise it to a square, and then outside the bracket I'm gonna have a 8 plus 48, and then a j2 raised to exponent 12 over 12 j raised to exponent 2. Outside the bracket I'm gonna have a 4. You still remember this, right?
Yes.
Okay, so let's simplify the j's inside the bracket. Gonna get a minus 1, 4, minus 36. We now have a j squared. It's a minus 1 raised to exponent 8 plus 48 j squared. It's a minus 1 raised to exponent 12 over 12 j squared. That's a minus 1 raised to exponent 4 equal to. Then we'll have to simplify this. You can punch this on the calculator and get an answer. I'm gonna write it down for each term. Let's start with the first one, 24. Hello?
Yeah.
Usasekhona?
Yeah, when you say I must punch the whole thing in the calculator, I have to do like 24 open brackets -1 close bracket to exponent 4. Then
Yes,
I punch this equals to,
yes.
and it's gonna be a positive 24.
A positive 24. But you know what? We actually don't need the calculator. We don't need the calculator.
Yeah.
We don't need the calculator. It's a minus 8, minus 1 raised to exponent 8. It comes out as a positive 1, right?
Positive.
So we're gonna have a minus 36 here, and then a minus what? Minus 1 raised to exponent 12. It's also a positive, so I'm gonna have a 48 over 12. Even here I'm gonna have a positive 1. So this is the answer. Yes, so this is what we end up with. 24 minus 36 plus 48 gives us what?
I must add them together. 24 minus
36
plus 48 is equal to 36.
it's equals to a 30. Yes, it's a 36. I also got the same.
Yeah.
I also got the same.
Right.
Over 12. What's the answer? I'm getting a 3. I'm getting a 3. All right. Any questions so far?
So you said you must never leave the 3 alone like this, and you must write 3 plus 0.
Ish.
0. Yeah.
Yeah, you are correct.
Yes.
You are correct. I should you alalele classy.
Yeah.
Yeah. So it's a 3 plus 0 I. Ne? 0 I.
Yes.
0 I. Okay. Yeah, we have that. I think we can proceed to the next one. Ne?
Yes.
We can proceed to the next one. So for the 2.2.3, we have a 4 plus 9j, 1 plus 5j raised to exponent 2. So we need to expand here, right? But first, you know, I see things, man, sometimes. Yabona, like, Bagnigas is something like this. People will end up multiplying like this. While there's a square, while there's a square. So try by all means to avoid that, ne? Even if mhlambe
Yes.
there's a case maybe like this as well. Maybe there's a 2 outside the bracket. Do not multiply by the 2 until you solve for the bracket, ne? Until you solve for the
Yes.
bracket. So first, before we even start multiplying, we have to deal with the squared bracket. So I'm just gonna write 2 brackets like this: 1 plus 5j 5j. So we're gonna take the first 2 brackets and multiply them. We're gonna get a 4 plus 20j, and then a 9j, and then a plus, what is 9 times 5? 45. Yeah, it's 45.
Say.
Yes, yes.
Is it gonna be wrong if I start with the brackets that I have expanded?
That's fine. That's also fine. That's also fine.
Is it gonna give me the same answer with the one that you are doing here?
Okay, you know what? When I tata the
Mm.
do it the way ofuna ukuyenza ngakhona, then I'm gonna do it like this, ne? And then let's see if we
Because
let's yeah
okay, yeah. Let's carry on.
yeah let's do it. I'm getting a
Uh,
45j squared. Then I'm gonna close this bracket and leave the last one as is. J equal to, then I'm gonna have a 4, the 20 and the 9 gives us a plus 29, a plus 29j plus 45. Since the j is squared, it gives us a minus 1. And then I'm gonna have a 1 plus 5j. Then we continue the 45, so it's 4 plus, you know what, let me just do it, 4 plus 29j, then 45 times negative 1, it's 45, negative 45, 1 plus 5j equal to 4 minus 45, negative 41. I have a negative 41 plus 29j, 1 plus 5j. Then we multiply. This times that, it's a minus 41. This times that, negative 41 times 5, it's a negative 205. Negative 205j, and then this times that gives us a 29j, and then this multiplies that. I'm getting a plus 145j squared equal to minus 41, and then minus 205 plus the 29 gives me a minus 176j and a plus 145 minus 1. Alright, so minus 41 plus the 145 with a negative 1. I'm getting a minus 186 minus 176j. Are you getting the same?
I think I did something wrong. Let me see. Negative 96. Oh. Yeah. It's the same answer.
It's the same answer, ne?
Yeah, yeah. One negative 186 minus 176I. Yeah,
Oh,
yeah.
okay,
It's the same. It's the same thing.
okay. But let me just double check with the calculator as well, so that
Okay.
sibone ukuthi sithole the same answer. Where do I get complex? Where's complex numbers? Complex. Mari right man. You sharp. E sharp.
Yeah.
E sharp. Oh, shift. Number 2. Okay. Let's just double check it quickly. 9I close bracket 1 plus 5 shift I close bracket then square the bracket. Yes, it is the same. It is the same answer. Okay, now let's take this down. 2.2.4. What is really happening here? They want us to simplify. What is really happening? What is really happening?
Yeah, we're gonna multiply with the conjugate of 2 plus j.
Yes.
Yeah.
It's actually 2
Yeah.
minus j. 2 minus j. It's actually a 2 minus j.
Oh.
It's multiplied by 2 minus j. 2 minus j. That's the conjugate. Okay. We take the denominator as is, then we just change the sign. Ne? Then we change the sign. This is going to be equal to j minus 2 multiplied by 2 minus j over 2 plus j multiplies a 2 minus j. So then we foil. J times 2, that's 2j. J times minus j, that's minus j squared. This negative 2 times that 2 gives us a minus 4. This negative 2 times that gives us a plus 2j over. Then with this one, you know what, let's just foil it out. Nah. Bega, this bracket is the same as this bracket. We have whom? The only difference is that it's a plus and a minus, right? Now
Yes.
udila nani the difference of squares instead of foiling. But I'm not saying do not foil. You can foil, but it saves time to just do this. Uthatha 2 times on a 2, you get a 4, and the positive j and multiplied by that minus j, you get a minus j squared like this, equal to. Then this and this combined gives us ubani. It gives us a 4j. This produces a minus 1. We have a minus 4. And then here I have a 4, a minus, and a negative 1. We simplify. Sibano 4j plus 1 minus 4 over 5 equal to, and then here I'm gonna have a minus 3 plus 4j over 5. Then we divide. Sitola a minus 3 over 5 plus 4j over 5. Then I convert it to decimals. Yes.
Okay.
Negative 0.6 plus 4 over 5, 0.8 j. 0.8 j. Let me just confirm. Shift I minus 2 over 2 plus shift I. Yes, it's the same. It is the same. It's the same. You know what? 2.3, 2.4. Do these two.
Do them.
Yeah, do them.
Okay.
Yes.
And then what I'm going to do is I'm gonna multiply the 2 with the 3.
With
That's
the
2 times 3.
For 2.3.
Give me
Yeah.
6. And then
Okay.
since I must write all the steps, then I'm gonna write 655 plus 50
Yes, yes,
together,
yes. You
and
got
then my final answer is 105 degrees.
105 degrees. Done. Done.
Yes,
Easy 3
yeah,
marks.
yeah,
Easy
yeah.
3 marks. Easy 3 marks. Yeah, wanna more especially this step. Don't do it in your head. Write it down. Write it
Yeah,
down.
yeah, yeah, yeah.
Because the moment you skip, Utoguti, I've allocated 1 mark for the final answer. I'm gonna
On
mark
its
this
own.
multiple. Yes. Okay. What we do is that we mark this multiplication, we mark this addition. So it's 1 mark, 1 mark, and the remaining mark goes to the final answer. Ne?
So it means I must just write everything steps by step.
Everything. It's gonna do you a favor. Trust me, it's gonna do you a favor that thing.
Okay,
Yeah.
okay.
Not only for AMA test, even for your exam. Do that as well.
Mm.
Yeah, do that. Alright, so for 2.4,
If this one it's negative, simply the following to rectangle. Uh, that's the one you're gonna use the formula of which one? Open
cos,
bracket.
yeah,
Uh, ish,
cos theta
say,
plus
yeah, let me write
I,
the formula.
it's this one, ne?
Yeah, cos theta plus I sin theta
Right?
minus R cos theta plus.
Okay, I'm gonna give you time to do this one. This was only guys are the final answer, ne?
Okay.
Yeah, I think totally charge a lot. Yeah, let's do it. Okay, so you have the square root of 2 cis 315 minus the square root of 2 cis 225 degrees, right?
Yeah.
Step by step. Minus square root 2, open bracket. You're gonna expand this to that, right? It now becomes a cos 315 degrees plus I times sine 315 degrees minus the square root of 2 minus the square root of 2 cos 225 plus I multiplied by sine 225 degrees, close bracket, equal to minus the square root of 2, open bracket, cos 315. Let's punch this on the calculator. I'm getting a 2, a square root 2 over 2.
Yeah.
I think something almost similar to this came out, if not test 1, maybe it was assignment 1. Ne? Then what I saw was that my students, they converted this to decimals like this.
Yeah,
1.
me too. I think I did in decimals.
Okay, 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 okay. Um, Let me ask why.
So I think it's better in decimals.
All right,
It can
all
be
right.
calculated better in decimal.
Okay, let me show you. Let me show you. It's actually way better if you write it like this. Ne? It's way better if you write it
Okay.
like this. But it's not like I'm gonna mark you wrong. Nangabufaga ama decimals. Ne? But for convenience, just leave your answers in sat form. Plus sine 315 It's a negative this time. It's a minus square root 2 over 2I, close bracket. Where is this negative coming from? Now Shayu sine 315, it comes out as a negative. So that negative, it changes this positive into a negative. Ngoba, a positive times a negative gives us a negative. Ne? Minus,
Yes.
I'll tell you something in a moment. 225, then it's a minus square root 2 over 2 plus, and then sine 225, it's still a minus as well. So nalana, it's going to be a minus square root 2 over 2I. You see, the moment you forget or don't write the correct sign here, this whole thing is wrong. Ne? Iba wrong. Depending on the mark allocation, sometimes they might say for writing this correctly there's a mark, for writing this correctly there's a mark. I think iba fair that way, ne? Iba fair. But however, if you get a mark here, whatever comes next, so iba completely wrong because of this wrong sign. Let's say instead of writing a negative here, you write a positive. Well, yabo say iba wrong this thing. Ne? It becomes wrong. So just pay attention to our signs work as well. Pay attention to your signs. Then we multiply. You take minus square root 2, multiply it by square root 2 over 2. So it's going to be a minus square root 2 multiplied by a square root 2 over 2. I'm getting a minus 1. I'm getting a minus 1. Okay. And then I'm multiplying that. I'm also getting a positive 1. This negative times this negative, it's a positive. I'm getting a positive 1I. 1I mul. Ne? And then this times that, it's a plus 1. This times that, it's a plus 1I equal to. Then this cancels that one. This and this isipa a 2 plus 2I. Remember, we need to write down 0 la. Because we are only left with 2b. And then a 0 right? So we are going to, had you worked with our decimals, your answer it was gonna come out as I think it was gonna be a 1.999 something. So, but it's close to 2. It's also correct. However, it's way easier if you work with the SATs. With the SATs. Yes. Any questions?
Yeah. And sometimes you know what confused me here is I forgot the I on I sign 315. I forgot to put the I there.
Oh,
So
okay.
that's why my thing was wrong.
Okay. Yeah. You know what? Just practice, my man. Practice.
Yeah.
Practice. Okay. So complex numbers for today, that's completed. Ne? That's completed. That's done and dusted. Okay. Let's get trigonometric. Let's
That one.
what's wrong with trigonometry?
The trick is very difficult. Like it has like many rules that has to be followed. And sometimes you just forget. Eh, and the moment you start to forget their identities,
Yeah.
that's why everything's gonna be wrong.
Yeah.
Eh,
Yeah.
ah,
Yeah. Yeah. To be honest, I don't wanna lie. Trigonometry has its own
Yes.
challenges. However, now though you're needing some practice, even if it means
Yeah.
writing down the rules or
Mm.
creating your, well, not creating your own rules, but just writing down your rules. It helps. It helps. Wabhale phansi and just try to memorize them. Uyabona? I think it helps.
Yes.
Let's start here. Trigonometric equation. Maybe we can start here. It's a trigonometric equation. All right. They want us to calculate to theta. Solve for theta. Solve for theta where theta is element of 0 degrees to 360 degrees. To 360 degrees. All right, what do we do here? How do we solve for this equation?
I think we have to make those two sine and cos. Maybe the other hand has to be sine, or the other hand has to be cos. They have to be the same somewhere, somehow.
Yes, correct. Um, you know what I would do? I would actually
Mm.
change the sign to a cos, right? I would do this. I would say cos 90 degrees minus 5 theta is equal to cos theta minus 40 degrees. Theta minus 40 degrees. Okay? Now, they are the same. They are the same. They are the same. However, if you
Yeah.
can solve this, you actually want this is actually a co-function, right? It's a
Mm.
co-function. So these types of equations, so with them are co-function types or co-ratio types. Co-ratio or co-function types. So you need to rewrite one of the ratios as a co-function of the other function, right? So now that they are the same, they're gonna cancel like this. We are now left with the 90 degrees minus 5 theta equal to theta minus 40 degrees. After the ratios have cancelled, the right hand side is taken as a reference angle. This is now considered a reference angle.
Okay.
Yes,
So say if from this step I don't have to calculate any further, just leave it like this.
you leave it like this. Leave it like this. Leave it like this.
Okay.
Then you're gonna decide on a quadrants using cast rule. Right?
Oh.
Cast rule. Right? Then since both the cos and the cos are both positive, they are both positive. It means
Mm.
that we are only interested in the quadrants where cos are positive. It's the first quad and the fourth quad. So our first solution, it's in the first quadrant. In the first quadrant, we're gonna have 90 minus 5 degrees equal to 0 degrees plus, no, not plus, minus 40 degrees. You itata the way it is. You don't add anything or subtract anything in the first quadrant. You take it as it is. Then you solve for theta. 90 transposing, we're going to transpose the 90 to the right and the theta to the left. We're going to have a minus 5 theta minus theta equal to minus 40 degrees. Then 90 comes over the side, about minus 90 degrees. Minus 5 theta minus theta. It's a negative 6 theta Minus 40 minus 90 gives us
negative 130.
negative 130. Negative 130 divided by minus 6 minus 6. Theta is equal to
21
0.67,
6, yeah, 67.
67 degrees. So this is theta. This is theta. Then fourth quadrant. In the fourth quadrant, we now have a theta, a 90 degrees subtracted by 5 theta equal to, since in the fourth quadrant we have a reduction formula, over there, which is 360. It's 360 minus theta. So the theta, it's that reference angle. So it's gonna be minus theta minus 40 degrees in brackets. Then we simplify 90 minus 5 theta, 360, remove the bracket, plus 40, and then it's a 90 minus 5 theta, 360 plus 40. What's the answer?
It's 400. Yeah, 400.
Yeah, it's 400 minus theta. Then we transpose about minus 5 theta plus theta equal to 400. The 90 degrees is transposed to the right hand side, about minus 90. Then we subtract, we add this 2. We add this 2. What's the answer?
308. Oh,
It's minus 4 theta more.
minus 4 is equals to 310.
310 divided by minus 4 minus 4. Ziyacancela. Then theta is equal to, what's the answer?
Negative 77.5.
Negative 77.5 degrees.
5.
All right.
Yeah.
Actually, this shouldn't be a solution. This is not a solution. You know why? Because of our theta should be between 0 and 360, and a negative 77.5 is not within 0 and 360. Yeah, what? So this is not a solution. This is not part of the solution. This is not gonna be part of the solution. All right. Any questions?
I don't have a question.
Okay.
I'm fine. I'm cruising nicely.
Okay. 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 All right. All right. All right. You know what? Let's just do two more questions. Just two more questions.
Yeah.
Two more questions. For trigonometry. Okay. That question ebesiyenza ngithethe from a previous grade 11 question paper. Now I'm taking directly from the NCV question paper again. Ne? This is trig. Check again now. Check. For 2.1, they want us to prove without the use of a calculator that this is equal to minus 1. Ne? You know what? Let's just be sure ukuthi this actually is actually gonna work. Asishaye ku calculator first and see if we do get the minus 1. Ne? Let's just double check. So we're gonna punch everything. Tan tan 150 times sine 300 and a cos 225 multiplied by sine 135. I'm getting the negative one, so it is true. It is true. We should be getting a -1.
Yeah, me too.
All right, so for 2.1, we're going to take the left hand side, this side, and solve that. So, cast diagram. Okay, we need to reduce the angles to our special angles. We need to reduce that to our special angles. So, for this one, I carry in the second quad, really 180 minus theta, a 180 plus theta, a 360 minus theta. All right, let's reduce here. Let's reduce. Let's reduce. Let us reduce. Let us reduce. Um, so 150. How are we going to reduce the tan 150?
Gonna be 180 minus 30.
180 minus 30 sharp. What about sine 300?
It's gonna be 360 minus 60.
Minus 60
Yeah.
over. Then cos 225.
It's 180 plus 45.
180 plus 45 sharp. The 135.
It's 180 minus 45. Right? 180 minus 45.
Yes,
180 minus 45.
correct. Okay, let's solve for the formulas. Okay, let's solve for these formulas. So tan 180 minus 30. Since it's in the second quadrant, it's gonna be a minus tan 30 degrees in brackets multiplied by 360 minus 60. This is gonna be a minus sine 60 degrees over cos 180. It's a negative cos 45 multiplied by sine 180 minus, it's gonna be a minus, no, it's gonna be a plus
Wow.
sine 45 degrees. All right, then we're gonna use our two triangles to simplify. Okay,
Yeah. Ah, one,
okay, 45 and then 45, 60, 30. Molar, it's 1, it's square root 3, it's 2, it's 1, 1, and then it's 2 molar. Okay, negative tan 30 degrees, it over mang.
one one over uh, square square root 3.
Yes, multiplied by
Yeah.
minus 60.
60 sine.
Mm.
It's gonna be a root
Yeah, it's root 3
square
over
root,
1
yeah, square 3 over 1.
sharp over negative cos 45. It's square root 2 more.
Cos wait,
More.
55. Yeah, 55 is gonna be it's adjacent to 1 over square root 2.
1 over square root 2
Uh, yeah,
multiplied by molar,
by
it's 1 over square root 2 as well. Ne?
1 square root. Yeah.
Okay, all right. So now, yabona, what you can do, what you are actually allowed to do, you can now take your calculator and solve in numerator, meaning that you can punch your calculator and calculate this, but we don't have to. We don't have to for this one, because this one, you cancel that one. And we are now left with this negative times that negative, it's a positive. It's going to be a positive 1. Our answer is going to be a positive 1 when we multiply these two. Over, then you can take your calculator and multiply these two and see what you get.
1.
It's also a 1, ain't it?
Yeah.
Alright. It's also a 1, but it's a negative 1.
Because of this negative here.
Because of this negative here. Then this positive over this negative 1 gives us a negative 1 as a final answer.
Negative 1. Yeah.
A negative 1 as a final answer. Alright. We can take this down and move on to the next question. So molar is an identity. Okay?
Yeah, okay. You know, this other day, I made the mistake of see where tan is. I put the identity there.
Oh, okay.
Yeah.
All right. Yeah, for these types of problems, where they want you to solve without using a calculator, and that there are angles in degrees, you don't have to change tan.
Okay.
Yeah, don't forget that. All right. So for this identity, which side are we going to take?
On 2.2.
Yes, 2.2.
The left hand side. Oh. Yeah.
Yeah, the left hand side.
But
The left hand side. Utlobali sine 4 theta minus cos 4 theta. Right? So, you know what?
yes.
We need to have a discussion on factorization at some point, because with this thing. This is actually a difference of two squares. This is a difference of two squares. Only x squared minus y squared. Simplify this or factorize this. It will be x minus y, x plus y. Do you agree?
Yeah, yes.
Alright, if you have an x raised to exponent 4 minus y raised to exponent 4, you're gonna get a x squared plus y squared over, open bracket, x squared minus y squared. There's also another difference of squares. You continue. Y plus y. So what I'm trying to say is that the moment ubanama exponents as even numbers, small, and between the two variables there's a negative sign, it means that in order to simplify that, you're gonna use Ilogai difference of squares. Even if it's a 6, no, except for 6, but nah, I think you can. Nah. 8, 10, 12, something like that. As long as your exponent is an even number. It's an even number. Then you can use the difference of squares. So now, Lana, we have that case. We're going to do the same thing. We're going to have a sine squared theta plus sine squared theta, open bracket. Then we have a sine squared theta minus cos squared theta equal to, we just factorized, but this is an identity.
Why here
Yeah,
say you wrote sine square theta plus sine square theta? Isn't like sine square theta plus cos
yeah, mistake.
square theta?
It's a mistake.
Uh,
It's a mistake. I got a little excited when I wrote this. More like cos squared. Yeah, it happens. While I
yeah,
was
yeah.
while I was writing this, I was thinking of the next bracket. That is why. Okay,
Uh,
so this is an identity now, right? Is an identity which gives us a 1. I'm
one.
left with the next bracket, sine squared theta minus cos squared theta. How do you suggest we proceed or move from here? What's our next move from this point?
I think we should change. See, we're gonna multiply the one with in both
The
one
sine and the
times
cos.
sine squared. Yeah, and
Yeah.
then from there we're gonna take the identity. We can change the sign into one minus cos
Yes.
cos
1
squared
minus
squared. Yeah,
cos squared theta
one
minus
minus
cos
square.
sharp.
Yeah,
1. Then this and this combined give us a minus 2 cos squared theta, which is the same as the left hand side.
yeah, it's proven.
It's proven now. It has been proven. Okay, this one I don't have to do. 2.3. I don't have to. Hello?
Yes, I'm still writing it down.
Okay. Yeah, just take it as,
This one,
yeah, it's simple.
yeah.
It's simple.
So should I do it or?
You know what? Just take it
Eh,
as just as extra work for practice. Ne?
okay.
Yeah, just as practice, as some form of practice.
It's very simple. This one.
Yeah. Okay. We're gonna end our session shortly, ne?
Okay.
Yeah, shortly. So, however, I wanna bring this one as well. It's a trigonometry problem as well. This one.
Yeah, yeah. I wanted to ask you about that one. Where's my textbook? Calculate the magnitude. What is magnitude say?
What is magnitude?
Uh,
Okay. Let me let me say magnitude. Size. What else? There's another term they like using, man. Size. Yeah. Until I remember then the other terms they like using. Ne? So magnitude. When they say calculate the magnitude, they want you to find the size of that angle. Ne? They want you to calculate the size of that angle. Okay. Do you see that for 2.4, they don't tell you which rule to apply.
Mm.
So now the question I want to ask you is, which rule are we going to use for this triangle in order to calculate the the magnitude of f?
Sign rule. Sign rule.
The sine rule, right? It's gonna be
Yeah.
the sine rule. And then which pairs are we going to use?
The angle of E with and that side of D, the length of DF,
Okay.
and then yeah,
And the
then we're gonna use
size
another.
and the unknown size f. Then we're gonna pair it with the 5.8, and we're gonna pair these two as well, right?
Yeah.
So that's what's
Yes.
going to happen. However, nine tokomeluyense again. Whenever they want you to calculate an angle, make sure that abu sine bahlala phezulu, ne? The sine of that angle, it becomes the numerator for the ratios. So it's gonna be sine of angle f over 5.8 equal to, and then it's also gonna be a sine of 126 over the sine, no, not the sine, but over its opposite angle, the opposite side, which is 12.5. Then from here, inst- don't do the do not do the cross multiplication. Save yourself time. Just take this and multiply it over there. You're gonna end up with a sine f equal to 5.8 multiplied by sine 126 degrees over 12.5. Then you calculate again. Then you calculate. Then you calculate.
5.8 attached it. 0.375.
375. Then we calculate
Yes.
the angle F, which is sine of that 0.375, gives us what?
22,024.
22,02. Yeah, 4 degrees. So that's the angle for this one.
Yeah.
All right, for that last question, they want us to calculate the perimeter of triangle DEF. Do you know what the perimeter is?
Perimeter.
Yes.
Uh,
All right. Maybe nangabuza this question this way. If you came across a question efana nale in an exam, bozo wenzani, what were you going to do?
I was gonna add all the all the length here of this triangle.
Yes, that is the perimeter, my guy. That is the perimeter. So
Oh.
yeah. So, so the 5.8 should be added to the 12.5. However, I'm missing a third length, which is the EF. Do you see that?
Yeah.
Yes, which is the EF. That is the missing length, the EF. So what do we do? What do we do? We have to calculate the EF. Now the question is, how do we calculate the EF?
We still uh, I yeah, we're still gonna use the same rule to
The
find
sine rule. Okay.
to find the EF.
Mola, we just calculated again. we got 22.024.
For
Okay, yes. Now, how do you propose we calculate EF?
it's gonna be sine. So we can still use the same method, but we're gonna change. Let me see. I, I, this one, this one. Yeah, we're gonna use the. We don't have the. What's it? This one.
Okay, try to think. Try to think.
This one. This one. Oh, say first we need to find the angle of D.
How do we calculate the angle of D?
This is a triangle and it's add up to 180. Then we
Okay.
will have to add the angle. So it's
Yeah,
gonna be
so
180 minus angle E
which is 126
plus
minus
angle F.
22.024. So we're gonna subtract everything from 180. What's the answer?
180 minus 126 minus 220. 31,976 angle B.
Yeah, okay.
31,976.
Yes, that's angle D. Then you can use the sine rule to calculate EF.
Great.
Eh?
Yeah, EF.
To calculate EF. However, even the cosine rule you can use, since you have the angle D, which is that 31 degree. You also have the sides adjacent to this angle, between this angle. You can now calculate EF, right? After finding this length, you're gonna say, to get the perimeter, you're gonna say 5.8 plus 12.5 plus the unknown length, which you're gonna calculate using either the sine rule or the cosine rule. Then you're gonna get your answer as the perimeter, right?
Okay.
As the perimeter. Okay, but tomorrow we're gonna continue with this, with the cosine rule, because I need to show you the applications where they talk about angles of inclination, angle of depression, something like that. We're gonna discuss that tomorrow.
In
Yeah,
class.
yeah, in class.
Oh, okay.
Yeah,
Because
and then
there are also some questions where they ask about the area, calculate the area.
yes, we also wanna calculate the area.
Oh, okay.
Yeah, we also want to calculate the area. Then sometime, okay,